Welcome student. Today we learn ZENER diode, light emitting diode, transistor logic family. In previous lecture, we discussed on semiconductor. Now let's start to learn ZENER diode. A ZENER diode, also known as a breakdown diode, it is a heavily doped semiconductor device that is designed to operate in reverse direction. When the voltage across terminals of ZENER diode is reversed and the potential reaches the ZENER voltage, that is the new voltage, the junction breaks down and current flow in the reverse direction. This effect is known as a ZENER diode. See the diagram of ZENER diode. The ZENER diode circuit symbol, see the circuit symbol, place two tags. The end of the bar, one is the upward direction and other is a lower direction. This helps in distinguish ZENER diode from other form of diode within the circuit. A normal diode allow current to flow only in one direction, while ZENER diode allow current to flow in both directions. After that, see the light emitting diode, that is LED. Light emitting diode, LED, are basically PN junction. When light emitting diode LED is a forward biased, free electron in conduction band recombines with the holes in the valence band and release energy in the form of light. See the diagram of LED. A normal PN junction diode allows electric current only in one direction. It allows electric current when forward biased and does not allow electric current when reverse biased. Thus, normal PN junction diode operate only in forward bias condition. Like the normal PN junction diode, LED is also operate only forward bias direction. To create an LED, the N-type material should be connected to negative terminal of the battery and P-type material should be connected to the positive terminal of the battery. In other words, the N-type material should be negatively charged and P-type material should be positively charged. After that, we see the various application of LED is used in calculator, picture phone, traffic signal, digital computers, multimeter, microprocessor, digital watches, automotive heat lamp, and camera flash. After that, we see the transistors. A transistor is a three-terminal semiconductor device that can perform two functions that are fundamental to the design of electric circuits. Transistors are categorized into two types based on their construction as bipolar conjunction transistor, that is BJT, and field effect transistor, FET. The bipolar junction transistor. The operation of transistor depends on both majority and minority carriers. The voltage between two terminal control the current through the third terminal. So it is called current control device. In this transistor depend on the negatively or positively carries. It is minority or majority carries. So it is called current control device. It can be used as an amplifier and logic switches. BJT consists of three terminals. See the diagram. That is these are the three terminals, that is collector, base, and emitter. This BJT junction transistor having two types, PNP and NPN. This PNP having two P-type material and one n-type material. Whereas here, two n-type material is used, then one p-type material is used. The emitter, see here, emitter in the transistor, emitter supply a charge section of the majority carries. So the emitter supply the large section of majority charge carries. The emitter is always forward biased. Emitter is always forward biased with respect to base so that it supply the majority charge carries to the base. The emitter of transistor is heavily doped and moderate in size, whereas the collector in the transistor, the section that collect the majority of charge, carry supplied by the emitter. Majority of charge supplied by the emitter is called collector. The collector based junction is always reverse bias. Collector section of the transistor is moderately doped but larger in size so that it can collect most of the charge carries supplied by the emitter. And the base, the middle section base of the transistor is known as a base. The base form two circuits, the input circuit with the emitter, input circuit with the emitter, and output circuit with the collector. The emitter base is a forward bias. Emitter base is a forward bias and offer low resistance to the circuit. The collector base junction is a reverse bias. The collector base junction is a reverse bias and offer higher resistance to the circuit. The base of transistor is a lightly doped and very thin, due to which it's offer the majority charge carries to the base. After that, you see transistor as a switch. A transistor consists of two junctions which can be biased in different way. The different working modes of transistor based on the different junctions. See here, there are 4 cases. In first case, two junction, emitter junction and collector junction. Here in this case, the emitter base junction is a forward bias and collector base junction is a reverse bias. The transistor is in the active region. Transistor is in the active region and collector current depend on the emitter current. Collector current is depend on the emitter current here. The transistor which operate in this region is used for amplification. In this region, the transistor is used for the amplification. In next case, both the junctions are forward bias. Here, emitter and collector, both the junctions are forward bias. The transistor is in saturation. The transistor is in saturation and the collector current become independent. The collector current become independent of the base current. In this case, the transistor act like a closed switch. In next case, third case, that is RR. In this case, both the junctions are reverse bias. That is, emitter and collector both are reverse bias. The emitter does not supply the majority charge carriage to the base, because of which the carriage current is not collected by collector. Thus, transistor in this case act like a closed switch, or you can say cut off. Okay. Then in next case, that is reverse bias and forward bias. Emitter is a reverse bias and collector is a forward bias junction. As the collector lightly docked compared to the emitter junction, it does not supply the majority charge carry to the base. Hence, poor transistor action is achieved. So in this case, transistor is invert. Okay. After that, we see a switch mode power supply, SMPS. It is a type of power supply that uses semiconductor switching technique rather than the standard linear methods to provide the required output voltage. See the block diagram of line SMPS power supply. See here. AC line voltage is directly reflected and filtered to the produce high voltage raw DC, which is fed to switching element like a transistor, where chopped to high frequency about 20 kilohertz high voltage square wave, and a resulting square wave is fed to step down isolation. And transformer and resulting secondary voltage is reflect and filter produce low voltage DC output. In order to regulate output even through input change, a portion of monitored and feedback into the control logic, it compare this voltage with reference adjust conduction period of switching element to regulate the output. After that, we see logic family. The digital integrated circuits are designed using bipolar device or metal oxide semiconductor, SMOS, or a combination of both. There are two kinds of semiconductor device. The logic family, which fall under the first kind, bipolar logic family, and other is unipolar logic family. Bipolar logic family consists diode transistor logic, that is DTL, and emitter coupled logic ACL, transistor logic TTL, and unipolar logic family consists P-type MOS, that is PMOS logic, then N-type MOS, NMOS logic, and complementary MOS, CMOS logic. That we see the parameters of logic family. In logic family include speed, fan-in, fan-out, noise immunity, and power dissipation. So the first, the speed of logic circuit is determined by the time between the application of input and change in the output of the circuit. Then fan in, it determines the number of input the logic gate can handle. It determines the number of input the logic gate can handle. Then fan out, it determines the number of circuit that gate can drive. Then fan in, determine the number of inputs logic gate can handle, whereas the fan out determine the number of circuit that gate can drive. Then noise immunity. Noise immunity means ability of logic circuit to tolerate the noise voltage. Here, ability of logic circuit to tolerate the noise voltage. After that, power dissipate. When a circuit switches from one state to other, power dissipate. In other words, the power dissipation is defined as the power needed by the logic circuit. Yeah, power needed by the logic circuit. Okay, we stop here. Thank you, students.